right, last section in our polynomials unit, and this is actually supposed to be not 10-5, but 7-5. That's a typo. Not quite sure how I did that, but who knows. Okay, so remember from our quadratics unit that when we solve quadratics, they always have to be set, all quadratic equations must be set equal to 0 to be solved. That's really important, and we'll talk a little bit more about why that is in a minute. We've actually already talked about it, but we'll see how many of you remember. Okay, so let's go ahead and try one. So I have n squared equals -3 plus 4n. So right off the bat, if we're going by this, we know this is not set equal to 0. I will tell you that it doesn't matter which side the 0 is on, because both sides are equal. It's irrelevant which side the 0 is on. One thing you do have to make sure, though, is make sure that the squared term, our n squared or our x squared or 5x squared or whatever, make sure that that squared term is positive. It makes life much, much, much easier. So if it's not positive, you can multiply the entire equation by -1, or you can just swap sides of the equation. So all of this needs to come over to the other side, and when terms, each of these are a term, -3 is a term, 4n is a term, switch sides, they also switch signs. Because they're having to do the opposite to get to the other side, right? If you go up, you have to go down. Move left, you have to move right. So when these move to the other side, they're going to change their signs. So we're going to put them in standard order. The opposite of 4n is -4n, and the opposite of -3 is +3. Okay? Now we have something that's factorable. So everything's set equal to 0. So now I'm going to find two numbers that add up to -4 that also multiply to 3. So the only thing that multiplies to 3 is 3 and 1, or -3 and -1. If my sign in the middle is negative, this is positive, then both of these have to be negative. So I have n minus 3 and n minus 1 equals 0. Now I want you to think about what we did in section 7.3, which was solving with factors equal to 0, because now we're at this point. And what that said was zero product property. You have to remember that each of these factors, if one of those is 0, when you multiply it by the other factor, no matter what it is, your product is also going to be 0. Okay? So this is where you're going to set up two equations, n minus 3 equals 0, and n minus 1 equals 0. And what numbers would those have to be to solve those? So the only thing that you can add to -3 to get 0 would be +3. And the only thing you can add to -1 to get 0 would be +1. Okay? So those are the two really important things that you need to remember. Make sure that your x squared, n squared, your squared term is positive, and then you're going to use zero product property. Okay, so let's do the second one. So 7a squared plus 2a equals 5. So ask yourself if that's set equal to 0 like it needs to be. It is not. So my a squared term is positive. That's +7. So I'm just going to move this 5 over. When it moves sides, it also is going to change signs. So I would get 7a squared plus 2a minus 5 equals 0. So this time I'm going to actually use that Australian method, because kind of the more I use it, I kind of like it. So you're going to have 7a and 7a, and then we've got to put a 7 down there because we've got extra 7s up there. So they've got to offset each other. Okay, now I need to, my AC value equals -35, and my B value is 2. So I've got to come up with two numbers that multiply to -35 that add up to 2. So I know one's got to be positive and one's got to be negative. 35 is made up of 7 and 5. So if I have a positive 7 and a negative 5, 7 times negative 5 is negative 35. 7 minus 5 is 2. So those have to be my factors. Then Australian method says, okay, now is there a number that can factor out of anything? Well, I can take a 7 out of that. So 7 would give me a plus 1. 7a divided by 7 is 7. 7 divided by 7 is 1. I can't take anything out of 7a and negative 5, but that 7 on the top and the bottom will cancel. So now I can set all of that equal to 0. This has been actually set to 0 the whole time. Just forgot to write it down. So now you would have a plus 1 equals 0. Here's one factor. Here's another factor. And 7a minus 5 equals 0. Now you're just simply solving. So it has to subtract 1 from each side. So one of my factors is, one of my solutions, these are factors. These are going to be our solutions down here. And the other one would be 7a equals 5. So it'd be a equals 5/7. I actually really like this Australian method the more and more I use it. So I might do another one down lower just to get a little bit more practice on it. Okay. All right. So I'm going to kind of throw a couple of other things at you that you've seen before, and it'll start all kind of coming together as to why we'd want to use these. So find the zeros of each function or polynomial. So terms that are interchangeable, that mean the same thing. Okay. So one is a solution. Okay. Sorry. We also can call those solutions a root. We also can call those solutions an x-intercept. This should sound familiar to you. We've talked about this in class quite a bit. And the last one we would call a zero. The reason it's called a zero is because on our x-axis, all of those values of y are 0, right? So if we find those points, any of these solutions that you find for a quadratic are going to be where our function sits on the x-axis, which makes it really easy to graph. As soon as you have two of those, knowing these are all going to be parabolas, all be U-shaped, whether they're right side up or upside down, whether they're on the left side or the right side, doesn't matter. Something is, if it's got two solutions, it's going to cross through that x-axis. Okay, so let's try example 3. So we've got h of x, this just is in function form, equals 3x squared minus 2x minus 5. And we know that we are looking for our zeros. So we want that equation to equal 0, because that's going to tell me where my y value is 0, which means it's going to sit on the x-axis. Okay, so I'm going to go ahead and use x factor this time. I'm going to use different methods every time that I solve one, just so that you have plenty of opportunity to decide which method you like the best. And that might change. You might like it more for some than the others. It's fine. So a value in your variable, a value in your variable. Your AC value is 3 times negative 5, which is negative 15. Guess you guys don't need it over there. Let's put it there. And your B value is negative 2. So in order to find two numbers that multiply to negative 15 and add up to 2, I would have negative 5 and positive 3. This does not reduce. This does to x over 1. So my two factors would be 3x minus 5, and I need to set that equal to 0, and x plus 1 equals 0. So one of my factors is going to be negative 1. The other will be x equals 5/3. So when we go to graph this equation, one of my zeros is going to be at negative 1, and one would be at 5/3. So somewhere, if I were to sketch that parabola, it would look something like that. The axis of symmetry would actually be right in between these 2 points. And we've actually already done that a little bit in the quadratics unit, but we will definitely work on that a little bit more. All right, example 4. Let's do f of x equals x squared minus 5x minus 24. Hopefully this one should be nice and easy that we don't even really need a method. We just need to add and multiply. So we're going to set it equal to 0. I've got 3 goobers looking through the window at me right now. Corey, Suki, and another one who ran away. So we're going to have 2 numbers that add up to, monitor is going to sleep, yes. 2 numbers that add up to -5 that multiply to -24. So again, I know one of them is going to be positive, one's going to be negative. I know that 8 and 3 multiply to 24 and they have a difference of -5. My larger number is going to follow that middle sign. So 3 minus 8 is -5. 3 times -8 is -24. Now I'm just going to set each of these equal to 0. So I would have to add 8 to both sides. I hope you're starting to see that your solutions are the opposite of your factors. My factor was -8, my solution is +8. My factor was -3, my solution, or sorry, my factor was +3, my solution is -3. Okay, so I'm going to give you a couple more at the bottom that I'd like you to work on independently. I'm going to actually solve both using the Australian method, just to give myself some practice. So whether it tells you to solve or to find the zeros, those mean the same thing. Okay, so let's do 11c minus 5 equals 2c squared, and g of x equals x squared plus 13x minus 48. So go ahead and try those on your own, and then hit pause and then come back and we will do those using the Australian method. Okay, so I need to move everything to, I'm going to move everything to the right side because my c squared is already positive over here. And it doesn't matter what I move, so I'm going to move what will keep that positive. So I'm going to move these to the other side, and when I do that, both signs are going to switch. So 0 would equal 2c squared minus 11c plus 5. So I've got 2c and 2c. And then I have a 2 on the bottom. I need 2 numbers that multiply to 2 times 5 is 10, that add up to -11. So I already know that both of my signs have to be negative. A negative times a negative gives me a positive. A negative plus a negative gives me a negative. So I already know that. And the 2 things, I either can have 1 and 10 and 2 and 5. Well, 2 and 5 adds up to 7, but 10 and 1 add up to 11. So 10 and 1. Out of this, I can factor a 2. So I would have 2 times c minus 5. Out of this factor, I can't simplify, so I'm just going to leave it like that. Divide everything by 2. Those 2's cancel. So I get c5, and all of this is being set equal to 0 every time. Okay, equals 0, and then 2c minus 1 equals 0. So one of my solutions is c equals 5. And the other would be c equals 1/2. Okay, working on example 2. Again, I'm going to set this equal to 0. This is already set up so that I have what I need. Now, I'm going to go ahead and use Australian method. You can use it even when this is a 1. Okay, so I have x, 1x. I'm just going to use x, and an x. And it's also going to get divided by 1, which is just the same. So it's still, even though that a value is 1, the same method works. So this is going to be -48, so I know one of my factors has to be positive and one has to be negative. And to get 48, I can have 12 and 4, 6 and 8. What else do I have? Half of 6. Ooh, it just got dark in my classroom. Half of 6 is 3. Half of 6 is 3, and double of 8 is 16. Half of 4 is 2, and double of 12 is 24. I think I got them all. Okay, and the 2 that have a difference in between are 16 and 3. So double check. 16 times -3 is negative 48. 16 minus 3 is 13. Now I have a 1 on the top and the bottom, so that makes my equation even easier. X plus 16 and 0 equals x minus 3. So one of my solutions is x equals negative 16 and the other is x equals 3. Okay, great. This is the last section in our polynomials unit. See you soon.